Hey folks, my name is Paul and this talk is called Global Variable Oriented Programming. It's really a talk of three parts. First, we're going to look at how we pass data around between parts of our application. Second, we'll look at how SwiftUI uses an environment to solve this problem beautifully. And third, we're going to re-implement environment from SwiftUI by ourselves from scratch in pure Swift so it works also in UIKit code, so you can really understand how SwiftUI's environment works. Along the way, we'll use some powerful features such as combine, type erasure, property wrappers, reflection, and more. It's going to be awesome. This video is sponsored by Instabug, who make it super easy to find and fix bugs in your code. Add their API, you'll get things like device details. You'll get reproduction steps with every bug report. Go and check them out at this URL right here for more information. Let's back up and talk about classes. Classes were used everywhere in Objective-C, and so folks like me who came to Swift from Objective-C wrote Swift originally very much like it was Objective-C. We use classes in lots of places. Not great though, because problems exist everywhere with classes. For example, they have ambiguity. If I say make a new target and make the name of that target be Death Star, and assign that target to Luke Skywalker, we can say Luke will begin his trench run on the Death Star. Awesome. But his buddy, Wedge Antilles, he gets hit. He's got to return home to the Rebel base for repairs. So we'll say target name is Rebel base. And Wedge's target is that target. But what does that code do? And the answer is we can't tell. Unless we look at what target actually is it a struct or a class, we've got no idea what that code does. Because structs always have one unique owner. When two different things point to a struct, they have their own unique copies of that struct. Change one, the other does not change. But if it was a class, they both point to the same instance of that class. Changing one changes them both. Look again. They both use the same target variable, which means if target is a class and not a struct, changing the name to be Rebel Base means Luke will stop his attack on Death Star and instead bomb the Rebel Base, leading to all sorts of confused cinema goers. Now we all understand that shared access to data causes all sorts of problems. But classes are used everywhere in Apple's APIs. UIKit, AppKit, WebKit, MapKit, SpriteKit, SceneKit, and more, they're all Objective-C based, so they're all class based. And so we kind of settled into a nice place. We said, let's put all our data on one side of this line. They're all going to be structs. And our strings, integers, arrays, doubles, booleans, tuples, and more, they're all structs. On the other side, the classes, there are views. So UI view, table views, view controllers, web views, map views, and more, any kind of layout stuff on the class side, any kind of data on the struct side. A very simple rule. Of course, we still have to have a way to transfer data around our application so things stay synchronized. How can we do that so when it changes here, it also changes here correctly, synchronized? And so when you're just learning, you think long and hard and have an amazing idea just pop into your head. And it's this. If all these things have to share their data, then all you got to do is make them all point to some kind of external shared data that's available from anywhere in your application. Boom. Problem solved. You've just invented global variables. You can get back to wasting time on Twitter. Until it comes to code review, where things will not go down so well. They'll ask, how can we share data? You've proposed global variables, and, well, things don't go so well. Of course, the experienced coder here, they know global variables are bad. They've read the Gang of Four design patterns book. And so, they'll take that shared data, and they'll wrap that inside a class, and make it have a private initializer. And they say, that's not a global variable, that's a singleton. Well, folks, I have some bad news for you. Singletons are just global variables with fancy names. They're nothing special at all. And they suffer from many of the same problems as global variables. Global variables have all sorts of concurrency problems. If you're reading them in various threads, they interact badly. They become hidden dependencies. You can't tell where they're used, therefore they're harder to test and mock. And of course, they have namespace pollution. And singletons, they give us exactly the same set of problems as global variables, with one important difference, an improvement. We now get getters and setters. But having a fancy name really makes a difference, because we use all sorts of singletons. UIDevice.current, userdefaults.standard, file manager.default, and more. They're prevalent in Apple's platforms. So you bite the bullet and you start adding code to make your singletons testable. That means you've got a view controller that has some kind of UI application. That's bad. That's a hidden dependency. So you make a protocol called URL opening. You make UI application conform to that. Then make an app mocking version of that, which also conforms to it. And now, hurrah, you can use your protocol. Great. You can inject your value. Brilliant. But then you repeat the process for your other singletons. Settings, networking, logging, core data, analytics, the bundle, and many, many more. And any one of those individually will make perfect sense. It's only one app. It's only one settings, only one logger, only one core data stack and so forth. But then you've got a new problem. It makes it really, really hard and ugly to create all these protocols and then inject them onto a massive, massive initializer, taking all the things you have. And then, amazing, another idea comes to you. What we're going to do is take all these singletons and put them inside a container that's also a singleton. And we can call that the environment. A super singleton. A singleton of singletons. This is a fantastic place to dump code. If you thought App Delegate was good, nah, put it in this environment singleton. Just dump things in there. No one will ever know. I should say, by the way, this is actually the approach Kickstarter uses. And it can be a great approach. They've shown it really, really works. They call it the environment. It has 29 parameters being passed into the initializer, and it does work. And it has some advantages. For example, they can go between testing and production across their whole app by just changing one single environment struct, and everything else adopts it. If you want to find out more about this approach, go and watch Stephen Sellis's talk from NS Spain at 2018, I think it was, called How to Control the World. Very good talk, highly recommended, and a great conference too. Okay. There are lots of ways you can wrap up your global variables in a fancy way. You may have one singleton or many singletons in one super singleton, but no matter what you choose, we still have this beautiful clear divide. Our data is structs. Our views are classes. We divide them down the middle. This is Swifty. This is idiomatic Swift. It took us a few years to figure out, but we got there, and now we can focus on actually building great applications. And that, of course, is the end. Everything's awesome. We're done, right? Nah. You see, if there's one thing Apple loves, it's disruption. And at WWDC 19, of course, they introduced SwiftUI. Just when we thought we had everything understood, this new thing comes along. And in SwiftUI, they made one fundamental change. Our views were now structs, and our data became classes. Hooray. Yes, this means multiple views can now change the same data. It's not a car, it's a cat. And if any one view changes that, all the other views get the new value. So why? Why is that better? Well, the SwiftUI difference is this. SwiftUI keeps them in sync for us. We can say our guest's value here is an observed object, a Swift property wrapper introduced in Swift 5.1 specifically for SwiftUI. And SwiftUI leans on them super hard. This will monitor that guest's type for changes. And when guest changes, it'll re-invoke the body property. It'll reload the view with those changes intact. You can see what's changed visually. And what it does is it compares our old view hierarchy against a new view hierarchy and tries to see what changed. In this case, it might say, well, actually, only this one small part has changed. So it only updates the UI for that one small part. And this is extremely fast. Even if you have hundreds of views, this tree diffing is very, very fast. And the best bit is, structs are basically free in Swift. This struct has no properties. It has literally 0 size. It does not exist when it's compiled. Nothing is stored here. If we had a single integer in there, this is likely to be an int64 on most of your platforms, so it'll be 8 bytes. The entire size of that player view is just 8 bytes, because views are always the same size as the sum of their property sizes. So we can pass data from view to view to view, each time using observed object. And if it changes, all the views update for us. Even better, we can avoid passing that data around. We can instead make it shared. So any view can read it back, rather than passing it from A to B to C to D, put it into the shared data area, and get it out later on. And SwiftUI calls this the environment. I call this a singleton. And now, having watched this talk, you'll now also call it a singleton. Because that's right, global variables are back, and better than ever. SwiftUI has a really new, exciting solution, but it's still just a singleton. And the solution, of course, is property wrappers here. It works brilliantly. It uses runtime reflection. So we can say there is an environment object of type user, and it'll find that and put it into the environment for us. It'll then use type names for the lookup, which is really, really clever. You can say, I want a user and a settings. And it'll say, well, I've got a user class and a settings class automatically and match them up to your properties. Plus, you can subdivide the environment if you need to. You can say, here's my environment, here's my child's environment with more things, and my grandchild's environment with even more things, and so forth. And if all this sounds familiar to you, there's a good chance you've been using Haskell. This is modeled on the Haskell's reader monad. So the end result, we've solved our problem of sharing data, and we get great data access in our app. It's really, really nice. Even better, you've gone from saying, I use global variables, to I use singletons, to I use the reader monad. True galaxy brain stuff. So surely, that's the end. We're done. Still not. You see, SwiftUI's environment really is awesome. It's a very, very beautiful solution, but it's only available in SwiftUI. So if you want that same behavior in UIKit, you've got to build it yourself. Now, I could totally end the talk here and leave you to fend for yourselves and build yourselves, but that wouldn't be fair. So instead, I'm going to, here in this talk, re-implement SwiftUI's environment for UIKit. Now, there are some provisos here. I want to make them clear up front. First, I am not re-implementing SwiftUI. That's a whole other massive thing. I'm just looking at the environment part of SwiftUI. And second, I will not be handling subdivisions. There'll be one environment for every kind of view in our app. But we will use property wrappers. We will use combine, reflection, type erasure, and more. There's lots to think about in terms of coding, plus hopefully a great starting point if you want to continue doing it further. Okay. So here are the 6 things we're going to try and work our way through for the remainder of this talk, starting with making our models publish changes. First, though, I want to run you through the app itself. I've made a very simple UIKit app to work with here. It looks like this. It's again a simple UIKit app with 3 tabs across the bottom: authentication, language, and summary. This first tab here has a button, toggle authentication. It does nothing right now. This language tab has the 2 great languages of the world, English and Singlish. And the summary tab has 2 labels, authentication status and chosen language. That's the entire app. Let's go and look at the code for this in Xcode. You can see there's one class here called user settings. It has a property here called is authenticated. It's a Boolean, false by default. Then below that is this computed property, authentication string, that turns that Boolean into either authenticated or anonymous. That's the entire user settings class. Then below that we have app settings. This thing has a single property called language. And this thing is English by default, but it's a string, so whatever you want to. That's the entire app settings class. Here's our first view controller. You can see it has its own property and instance of user settings. And then there is this button down here that toggles is authenticated between true and false. That's all it's doing. Over here, our second view controller, you can see we have our app settings as a property. Then in our segmented control, we have a language change method that updates the language property between English and Singlish, two awesome languages. Then in our third view controller, this has a user and an app settings. Both are those labels, but it's not doing anything with them. An empty view load in there. So our first task is to make our models publish their changes, to say, hey, my data's changed, reload your UI, please. And so back in Xcode, I'm going to open our types.swift file and add an import combine into here to bring in the combine framework new in iOS 13. This works great in SwiftUI for announcing changes, but it also works elsewhere, including in UIKit. And with that in place, I'm going to make two changes to our classes. First, I'll make user settings conform to the observable object protocol, and I'll make this property be @published. And the same for app settings, conform to the protocol and @published. Now, observable object is designed to let us announce changes from this class to say, hey, something's about to change. What do you want to do with that? And @published is what does the actual work of announcing changes. Behind the scenes, we get a property. The object will change notifier. And when that's triggered, anyone watching it somehow will be announced. And published triggers that. It'll say, hey, I've changed. What do you want to do with me? We've added that protocol conformance to both user settings and app settings and made both our properties @published. So we're saying these classes can be watched. They can announce changes. And in particular, those two properties should announce their changes. And that is our very first task done. Our models now can publish their changes. The second task, create an environment singleton. Fine, let's do that now. So back in code, I'm going to scroll down in types.swift, add a new class down here, the class environment. I'll say this thing has a property, which is static, which is a notification name. The message you're going to send out to the world saying, I have changed, what should you want to do? And it's got a unique string, environment changed update. So you can post that to notification center and have things respond appropriately. Next up, I'll say there's a new shared instance of the environment. This is our singleton. There's only one environment in our program, and it's this one. Only we can make it right here. And then I'll say there is a sinks array of any cancelable and a values array of any. And these two arrays are important. The sinks one is there to keep hold of all those notifications from Combine. All those publishers from Combine. I'm going to change, I'm going to change, I'm going to change, and so forth. They'll all be stored in sinks so they stay alive. And the values array, that can store the actual things we are storing in the environment. It's anything. You can put whatever you want in the environment. So we can say store settings, store app settings, store some other class, whatever you want to. It'll all go into that values array right there. So two arrays. And then critically, we'll have a private initializer that does nothing at all. This makes a singleton. Disallow anyone else from creating their own environment. They've got to use environment.shared. And that is our environment. Next, we're going to say, I want a new method called register. Store some kind of observable object in here. And when that's triggered with a value of that type, the first thing we'll do is say, great, go ahead and append that value to our values array, but also tell its change notifier, object will change, like when you want to actually change a value, great, sync that value or send that value into our update code. We'll go ahead and do dispatch asynchronously on the main queue to avoid problems, post our message with that value, saying our update's changed on this exact value of thing. And that will then be stored in our sinks array. So this really matters. We're saying to the object coming in, register settings, fine. When your value changes, run this code. Asynchronously tell the world my value has changed. Object value there on line 42 at the end of it. Tell the world I have changed. And that goes into a single constant sync and goes into our syncs array down here. And without that, we'd lose sync entirely. It would be freed up straight away and we wouldn't get the message. So storing that in our array really matters. And that is creating an environment singleton. Done. Next up, we want to register objects with the environment. Now, there are lots and lots of ways of bootstrapping your app. Okay. In my example code here, I'm using a storyboard. And storyboards are notoriously not flexible by letting you interrupt their code to do other stuff. And so I've got a quick shortcut hack. You'll have your own way around this, I'm sure. It's fine for this simple talk. We're going to go ahead and modify the app delegate. So when we make it in app.swift, we'll have an initializer in here that will launch as soon as the app delegate's made. And all we'll do is register a new user settings and a new app settings. But it's done there at the init stage for our app delegate. So it's done immediately. In your own code, you'll have your own init stack. Fine, put it where it makes sense for you. In this very simple storyboard app, there aren't many options in that respect. I've got to put it into here instead. And that's it. That is registering objects done. Next, making views handle updates. So let's look at that. Back in code again, I'm going to go to our types and make a new protocol down here. A protocol called global updating with one requirement. If you want to update with a global variable coming in, you've got to know how to update yourself. You've got to add an update method. That's our only requirement here. But I'm going to add an extension to that with a method called register for updates. I'll put more code in here later on. But it's not in the protocol. I do not want to mark this as an extension point for my protocol. It's extension so folks don't change it very easily. But they'll still get that method. There's more code here. We'll add it later on. That's a bit trickier. And now in our first view controller, we can say, well, this thing is global updating. And go ahead and register for updates when the view is first loaded. So it knows to update itself. And of course, this thing must now have an update method. What do you want to do? And we'll first print a message out, updating first view controller, and then change its title to its new value. So it reflects in the UI. Print a message, reflects in the UI. Then we'll do the same with second view controller. Make it conform to global updating. And then say register for updates and view to load, and make an update method, and print a message out so we can see what's going on, and set its title to be the correct language that came in. So we're just copying data across to reflect the change in our model data. And finally, let's do third view controller. Again, it conforms to global updating. Again, it registers for updates when it's loaded. But in its update method, we've got to update two labels. So first, print a message, and then update the first label with the value from user settings, and then update the second label with the value from app settings. And while we're here, give this thing a nice title. Okay, so that's our three view controllers now updated to handle their updates. They now understand how to handle model updates. So our next job is to mark the global properties to say this thing and this thing and this thing, whenever you want to. These are shared values in our whole application. And realistically, you're unlikely to have many of these things. You have a couple. Most properties will be local, used only in one view controller, or perhaps passed between two specific view controllers. Only a handful are global. So you want to tell Swift specifically, this one, these really are global. And so back in our code, I'll go back to types.swift and a new struct down here. A global struct, generic over some kind of observable object. It'll have inside it a property for the wrapped value, what's actually being stored, plus initializer. We're going to go ahead and make its value equal to the environment shared first value that matches that type. the first thing of that type in the environment. We'll do a quick typecast to make sure it's correct. If it is, assign that to our wrap value. If it isn't, we'll do fatal error. Just crash out. And that's exactly what SwiftUI does, by the way. If you say, hey SwiftUI, give me for the environment a type user, and there isn't one, bang, crash. It's a programmer error, don't do that. So the code here in line 64 will say, get me the environment singleton, look at its values, and find the first thing that passes this test. The object is some kind of our type we're working with, because it's generic. Some kind of app settings, some kind of user settings, whatever it is. And if that works, we'll do a quick typecast. If that succeeds, assign that to our wrapped value. Store that inside our global struct. Now, one of the great things in SwiftUI is actually a new feature from Swift 5.1 called property wrappers. It makes it super easy, lightweight to make these kinds of structs. And to do that, to make our global struct into a property wrapper, all we're going to do is scroll up and say @property wrapper before the struct. That's it. Swift will do the rest for us. It's absolutely beautiful. And now we can go to our first view controller and say, you are a global property. That's it. That'll make that type be wrapped inside our global struct, make it generic over user settings, and make it accessible from the environment. And so now here on line 12, we're saying, make a new user settings. We don't want that anymore. We want the environment's user settings. And so we'll change this code to be : user settings. We're not making a new one. We're just declaring its type. And then over in second view controller, we'll do exactly the same thing for app settings, @global, and a colon. And in the third view controller, again, exactly the same thing, @global, and then colon, like that. We're not making local instances anymore, using the environments version instead. And that has now marked our global properties. And now it's time for the final part of our program to receive change notifications. You've seen the environment, which stores values. You've seen @global, which reads them from the environment when they're created, but we don't have any code to actually watch for updates to those values. Like actually look for those values changing and do something with them. So it's time for some reflection. So we have this @global thing here. And if you remember, @global is really our property wrapper struct. That thing right there. So what I want to do really is figure out from our view controllers which properties should be monitored. Because we don't want to monitor all of them. That'd be absurd. It'd be extremely slow. We want to only monitor the ones that are property wrapper struct global. That type we made earlier. And of course, if you did load is lazy, you've got to be really careful about this. How can we make sure we are watching for changes correctly? And so what we're going to do is, in here, we'll use a mirror. Reflect ourself. And to begin with, I'm going to loop over all the children in ourself and print it out, then call update. That's it. Now the mirror will examine self, i.e. whatever conforms to global updating. That's our first, second, and third view controller. It'll examine those three and say, what do you have for me? It'll go over the children and just print them out and then call update. That update, of course, comes from our main global updating protocol. We know it exists. So this thing will loop over all the properties it finds. Let's give it a try. Run the program now and then go through and have a look at our log, and you will see it's printed out. I found an optional _ user settings where the value is an Alamak global, Alamak user settings, wrap value, Alamak user settings. Now Alamak's the name of the application, that's fine. Global is the name of our struct, we made our property wrapper struct, and user settings is the name of our class being shared inside. But you can see, like critically here, you can see that our property, user settings, is not actually an instance of the user settings class. It's an instance of the global struct that contains a user settings. That's why it's called a property wrapper. It wraps the property. Now, If we modify this to say, let's pull out the child value as a global user settings and then print out the child, so only print out children who are global user settings, let's see how that works. Again, let's run the program. There's a first tab. Boom. Our output's there. And you can see updating first view controller. Good, that's our string. Then the second tab. There's our string, updating second view controller, but no global being printed out. That's because the second one does not have a user settings. It has an app settings instead. So nothing's printed out there for its children. And a third tab, summary, again prints out a user settings. It has a user and an app settings, but the app one is failing our typecast, so it's not being printed out. Now, of course, in practice, you are not going to have exactly one user settings class in your globals. You're going to have other kinds of globals for your kinds of classes and perhaps more than one, maybe 3 or 4, who knows what. And so a simple typecast to user settings is not going to work. We can't do that here. It only works with my exact example. What we really want to say is some kind of global. Global any. I don't care what it is. So I'll change this thing to be global any. And when we do that, we've got a problem. We cannot make that typecast. And the reason for this is we've said our global will be some kind of observable object. So we've got to go down to that property wrapper and remove that constraint. Global can be now some kind of anything. We don't care what it is. And it's not bad. I mean, it's okay to do this because if you remember, we had that register method way up in our environment. We constrained it there to be some kind of observable object. So technically, we are still safe here because we are not going to get bad values in our environment still. However, this code is not going to do what you think it's going to do. Let's build and run and try it again. First tab, second tab, third tab. And there's our output. You can see our 3 strings, updating first, second, and third, but none of those mirror child outputs anymore. We're not seeing those values anymore. So it's not great. And the reason is this. This global any down here does not work like you'd expect because of covariance and generics. Now, covariance is the power to say we have an animal, and from that is a dog, and from that is a Samoyed. I have Samoyeds, by the way. Here's one of them, Aria. She's cute. Oh, anyway, these things, as a class hierarchy there, we can say that Aria is a Samoyed, and we know that is true. She's a Samoyed. But covariance lets us say, is she a dog? Yes, she is. Is she an animal? Yes, she is. And we can even go super vague here. Is she any? Yes, she is. Is she anything at all? Yes, she obviously is. That's covariance, and it's brilliant. But here we're saying our global user settings is that global any. And that does not work in Swift because Swift does not support covariance for generic parameters. You can't do it. With exceptions. For example, arrays. These have custom support in the compiler to handle covariance for their types. Because otherwise it'd be very, very annoying working with arrays. And so global any won't work. We can't do that. Instead, we're going to do a really, really small amount of type erasure. We're going to scroll down here and make a new protocol called any global. And all it's going to say is, give me any kind of wrap value as any with a getter. That's it. So it'll anonymize our global values to be any. And now, up in our struct global, we can say this thing conforms to our any global protocol. Has that one requirement. We're going to say it has any wrap value and return our wrap value as any. And with that type erasure in place, we can now scroll up to where we're looking at our typecast. And instead of doing global user settings, do instead any global. Any kind of global. And that will work. That will print out the child correctly. And with that type erasure in place, we can now rewrite our code here. Get rid of print child, and actually make some more spaces. There's a lot of code here. We're going to start by saying, add an observer for this object to watch for changes. So we'll watch for the message environment.update changed for this particular wrapped value we're looking at right now on the main queue to avoid problems. And when a message comes in, we'll call our update. So we're watching for that common message. Any kind of thing has changed anywhere in our application, but we restrict it to only the particular thing we are watching, our particular property type. So we don't get every message to every change ever, only things we personally care about. And when it comes in, that's when we go ahead and call update. For whatever that means inside our view controller, update itself, reflect those changes in its UI. And that finishes our code. We can now run it one last time. When you press the button, the title changes. And the summary changes as well. We can change the language to Singlish. Title changes and summary changes. They're all passing their values around smoothly and shared in a really clean, clear way. Let's wrap up. First, we all know that global variables are generally a bad idea. Now, of course, like most things, there are a handful of exceptions. But if global variables are the answer, you're asking the wrong question. And singletons really aren't that much better. Yes, they have getters and setters, awesome, but they're mostly just very clever global variables. However, we're stuck with them. They exist in many places in Apple's platforms, so we've got to use them sometimes. But SwiftUI's solution is brilliant. It takes singletons to the next level by leveraging some really powerful Swift features. But if you want that power in UIKit, you can roll your own. It's not magic, it's just Swift code. It's not as hard as you might think, and you will learn a heck of a lot along the way. Now, before I finish, I want to mention one more thing. None of this whole talk answers the question of whether an environment singleton is a good thing. Because if you walk away from this thinking, the main takeaway is Paul Hudson says we should use singletons, you've really missed the point. That is not what I'm saying here. What I am saying, and what I regularly say, is there is no silver bullet. It's fine to experiment because you will learn stuff along the way. Maybe your solution singletons. Maybe it's several singletons, bundled inside one super singleton. Maybe it's something like SwiftUI's environment or something else entirely. It doesn't matter. The point is we have many tools available to us, and it's important you find the right one for your team and your project. And with that, I really have reached the end. Thanks for watching. If you enjoyed this video, follow me on Twitter. I'm at 2straws. Even better, subscribe here on YouTube. I make many videos like this one, teaching you Swift, SwiftUI, UIKit, and much, much more completely free. And if you want to really accelerate your learning, go and check out Hacking with Swift Plus. It's a subscription service from me delivering every tutorial as Ultra HD 4K video plus article so you can watch or read and learn incredible things all online at hackingwithswift.com/plus.